Okay, so I came out with about 4.5, my VI equal to 4.5. And I'm just going to note that down over here. That my VI was equal to 4.5. And of course, velocity is in meters per second. Okay, now I'll give you another hint as to how I did this in case you forget. I know the potential energy on top equals the kinetic energy on the bottom. And this yielded a formula that said velocity was equal to 2 times the gravity times the height and the square root of that. I knew the gravity, I knew the height, therefore I know what VI was. And I'll even show this as VI. Okay, so I got 4.5 meters per second. And I've got an angle of 36.9 degrees. Okay, so basically it's the same as me having VI is the hypotenuse of my triangle, which is equal to 4.5 meters. And I want to find the adjacent, and I want to find the opposite. Well, let's see, I have three choices again. I got SO, I got Ka, and I got TOA. Let's see, I have an H in each one of these cases. One second. I have an H right here. So it means I've got a possibility of these two formulas. I've got the angle of each one, and it all depends on what I want to find first. I think I'm going to find the adjacent first. So my formula looks like it's going to be this one. The cosine of the angle is equal to the adjacent over the hypotenuse. Okay, and if I cross multiply this so that this goes away, that H ends up being right over here. And here's my formula. H times the cosine of the angle. So this becomes 4.5 degrees of 4.5 meters per second times the cosine of 36.9 is equal to the adjacent. And that's going to be equal to 3.6 meters per second. So this is equal to 3.6 meters per second, which is this guy right here. 3.6 meters per second. And I have space to do the other one. So that means H, let's change the color. Let's do it black. H times the cosine of the, times the sine of the angle is going to be equal to the opposite. And this becomes 4.5 meters per second times the cosine of 36.9 meters per second is going to, degrees, sorry, that's 36.9 degrees. And this answer is going to come out to, oh, lost my head a second here. Should have been sine. So the sine of 36.9 times 4.5 gives me 2.7 meters per second. And I just want to check and see if that answer looks reasonable. Yeah, I think it is. So this guy over here is going to be 2.7 meters per second. Now let's pause and take a look at what we have. We have an initial velocity coming down in this direction as the ball leaves a ramp of 2.7 meters per second. And we have an x direction velocity that makes up the VI of 3.6 meters per second. Don't forget, it is a combination of this one in blue over here and this one in green that makes up VI. And our goal was to find these values. And now we have them, and we've completed task 2. Okay, so task 3 basically says to fill in everything we've gotten so far. And we should be able to do that. In my case, I know what gravity was. Gravity was equal to 10 meters per second squared. For more accuracy, you could use 9.8 meters per second squared. Y is the distance to the courtyard, and that will be determined. Our ramp height, you're going to measure. Ramp H, you measure. VI, you calculate it as we just did. Vx, you calculate as we just did. And the ramp angle, you calculate as we just did. Fall time and distance are all that's left. And that brings us to the stop and think portion of task 3. Now it says, you have calculated the horizontal velocity. We know that what that was in the last segment. The second part of the question was where the package, in this case the ball rolling off the lamp, would land from the base of the mountain, or in our classroom simulation, what is the distance from the base of the wall outside in the courtyard to where the target's going to be, just as in figure 2. Now know you must recall that the formula d, distance, is a horizontal distance. Distance is equal, and that's in the x direction. Distance in the x direction is equal to velocity times time. And of course, it's going to be velocity in the x direction times time. Now, you already have this. You calculated this a little while ago. Your goal is to find the time. If you only know these two, you would know the distance from the top of our room from the wall rather, from this wall to where you're going to place the target so that the ball coming down the ramp hits the target. So you're trying to find D over here. And you already know Vx. All you got to do is know the time. So read the next section on your own. Stop and think. I'll help you read it. I realize that we're pressed for time, so I'll go through it with you. You have calculated the horizontal velocity Vx as the projectile just leaves the ramp. The second part of the question was where the package, the ball, would land, from the base of the mountains. Or in our classroom simulation, as I said a second ago, what is the distance from the wall in the courtyard to the target? Recall the formula D, distance in the x direction is equal to velocity times time. In the horizontal direction, v is equal to vx. If we only knew the horizontal time, our task would be done. But know that it is going to, here's what you have to remember, that the horizontal time equals the fall time. So we've got to find the fall time next. And we have two possibilities. As it says, there's two formulas on your formula sheet. One is y, velocity in the y direction final is equal to velocity in the y direction initial plus gravity times time. And the second is, don't forget, you're looking for time. Y is equal to Vy in the initial direction times t plus 1/2 gt squared. So you know y, and you know the velocity Vyi, you already calculated that, but look at that time. That's going to be hard. It's in two places, it's squared. That's not the formula we want. We really want the Vy final, just before it hits the ground, is equal to Vy initial plus gravity times time. Okay, we know Vy initial, we know gravity. If we only had Vy final, we could figure out what the time was. How do we figure out Vy final? Okay, look at your formula sheets and find a formula for Vy final and see if you could use that one. Now the rest of this I'm going to let you go through. Your task is to find a Vy final value that you could use so that you could use the formula Vy final is equal to Vy initial plus t. I'll write that down. Here's the formula we need. We want to use Vy final is equal to Vy initial, we already have that, plus gravity times time. What we want to do is, we know what this is over here. We know what this is. We have this. We know what gravity is. We have that. Put a star there. We're looking for this. Okay, but we don't have Vy final. If we did, we could use this formula. We could say that time is equal to Vy final minus Vy initial, okay, divided by gravity. But we don't have this guy. So before we do anything, your next task, and you're going to do it on your own, is to find Vy initial, Vy final using one of the formulas on your handout formula sheet. When you have that, you will know the time and you will know everything you need, almost, to find the final, to find the distance away from the wall. You will take the time and you will plug it into this equation right here, and you will now know the distance from the wall. Okay, I'm going to be helping you in class, but this is a pretty good primer as to what we did back January and February. Now I realize it's been a long time, but I will be there to help you. And if we choose to go ahead and finish this, it should be a lot of fun.